In this lesson, we're going to learn about scatter plots, another type of linear model. We're going to take a look at the correlations between bivariate data, and we're going to learn how to write a line of best fit. Here's an example of a scatter plot. Notice our plotted points are just scattered. They do show a relationship, but please note that these points are not connected. So we can see that we have time and grade, and we can see that we're studying for the midterm, and we're studying so many hours to review. And again, we can notice that there is a trend and there is a relationship between the amount of hours that we review and the grade that we get on the midterm. You can see as we put more hours, as hours of study increase, the grades go up. So for example, this individual studied 0 hours and made a 50. This individual studied 1 hour and made a 70. These two individuals both studied 2 hours. One made an 80 and the other one made an 85. Someone studied for 3 hours. One person made an 85, the other person made a 90, and so forth. So there is a trend and there is a relationship between the amount of hours of study up for the midterm and the grade that someone makes. Now remember, we do not connect the points. However, we can create a linear model in the form of y equals mx plus b, like we've been studying, by a line that's called the line of best fit. This line is just an estimate, and it just represents the trend of the points in our scatter plot. The line can pass through some of the points, all of the points, or none of the points. In this case, it really doesn't pass through any points, but it is a representation of our data. It gives an appearance of either a positive correlation, a positive slope. It could have been a negative correlation where we had a negative slope going down from left to right, or maybe the points were scattered all about, that there was no trend at all, and therefore there was no relationship between hours and grade. We will always write our line of best fit in slope-intercept form, y equals mx plus b. Correlation. This measures the strength of our line of best fit. When our ordered pairs, our points, our data points, are clustered close to our line of best fit, then we have a strong correlation. However, in our second example, we still see that we have a trend of an increase, but the points are scattered around the line of best fit. They're not clustered close together. So this would still be a positive correlation, but it would be weak. So when the points cluster close together, we have a strong correlation. And when they don't cluster, we have a weak correlation. Again, the correlation measures the strength of the line of best fit. So correlation, there are types and strengths. So the types are positive, negative, and no correlation. Then we have strengths. We can have a strong positive, like example 1. We could have a weak positive. We could have a strong negative correlation. We could have a weak negative correlation. Or again, no correlation at all. There's no relationship between the input and the output values. One does not affect the other. So when we are given example of an idea and asked to see if these variables have a correlation, we always ask ourselves, as the x values increase, what happens to the y value? As our input increases, what happens to the output value? So let's take a look at our first example. As the study time increases, what do you imagine happens to your math grade? It will also increase. This indicates a positive correlation. Exercise time. Again, you always ask as X increases, as exercise time increases, what happens to your body weight? Well, hopefully it decreases. So this would be a negative correlation. The more you exercise, it affects your body weight by making it go down. How about as the more pets you have, what happens to your math grade? I don't really think pets has anything to do with your math grade. I don't think the number of pets affects your math grade. So this would be no correlation. Number of pets has no effect on your math grade, or at least I hope not. So here we have a scatter plot. Again, let's take a look at the title. This is auto insurance, and we're looking at the years of driving and what you pay for auto insurance in a year. So notice that as years go by, as years increase, my auto insurance decreases. The more experience I have, the less I have to pay in auto insurance. So we're going to create a line of best fit. This has a negative correlation. It looks pretty strong. The points are clustered together. So when I do a line of best fit, I am just going to do my best and try to come close to as many points as I can. Now I have several points in the bottom, several points on the top of it. This is again just an estimate. The way I'm going to find my rate of change is I'm just going to take my first ordered pair, which is 0, 3200, and a second ordered pair, and again, it's just an estimate. So I'm just going to use this point right here. So this is like 24, and that's a difference of 6. So this is probably about 27. Let's say this point is 26. So this point is 26, 0. So I'm going to use these 2 points to find my slope. So we're going to have 0 minus 3200 over 26 minus 0. So guys, we're all going to probably have a little bit different type of answer, but we need to definitely make sure that we have a negative rate of change here. So we're going to have negative 3200 divided by 26. And a lot of times I do try to use, especially with a negative correlation, I try to use the y-intercept and an x-intercept. And so now when I divide this out, 3200 divided by 26, I get about 123. My y-intercept was 0, 3200. And again, we may be off a little bit, but that's about what it is in my eyes. So we put that together and write y equals 123 times x. Ooh, it's negative. Miss Thomas, don't forget, it's negative. It's a negative slope plus 3200. So we want to know how much is insurance with 15 years of experience, and years of experience, years of driving is my x. So we're going to plug in 15 for x and calculate. Again, we're all going to have a little bit different values here. That is okay. And we get, I got $1,355. Here we have a graph. There's no title, but I have a picture. So it looks like we're comparing hours of gaming to hours of sleep. So it looks as though the more hours that we gain, the less hours of sleep. I'm going to put in a line of best fit. We're going to find the average rate of change. So this looks like 0, 7 and 5, 0. So we're going to have 0 minus 7 over 5 minus 0. This gives us negative 2. Whoops, negative 7, I should say. Over 5. So our slope is negative, and I'm going to go ahead and say 7 divided by 5, and go ahead and get a decimal. My y-intercept is 0,7, and the equation is y equals negative 1.4x plus 7. It asks how much sleep will 2.5 hours of gaming, and gaming is the x variable. So we're going to plug in how many hours of sleep if we game for 2.5 hours. So calculate this. And it looks like 3.5 hours. That's not too many hours. We need more hours of sleep than that, guys. Here we have a positive correlation. So we have some money. So it looks like the more hours we work, the more money we're going to make. So I'm just going to pencil in a line of best fit, the best I can. Here are 2 nice points I'm going to use. So this looks like we have 0,14 and 4,70. When I find my rate of change, 70 minus 14 over 4 minus 0. So when we get that, 56 over 4, and that divides nicely into 14. And then our initial value is 0,14 in our equation. So this is the equation of our line of best fit, guys. It's just an approximation. So how much earnings with 12 hours of work? So we want to know how much money. And 12 hours is X. So we're going to replace X with 12. So that's a lot of hours working in a day. This person's also not getting enough sleep. So it looks like $168. Here we have another example. We're going shopping. So the more hours we're in the mall, looks like the money in our wallet is decreasing. So we have a very strong negative correlation. So I'm going to take 500, and then this is kind of going off a little bit. So let's try to make that a little bit neater. Try one more time. So the reason we have a line of best fit is also so we can make predictions. So once we get our equation, our line of best fit, we can make predictions. So we're going to have 0,500. We're going to start out with $500. And then another point on my graph. It doesn't always have to be at the end. Do I see another nice point? Let's see. Let's just go ahead and use this point here. Again, it's just an approximation. So we're going to have a rate of change of 0 minus 500 over 6 minus 0. That's negative 500 over 6. That's about negative 83. We're going to start with 0, 500. The equation altogether, y equals negative 83 times x plus 500. How much money, which is y, is left after 3 hours of shopping? So we're going to replace x with 3. So we're going to multiply that. And we have $251 left after 3 hours of shopping. Okay, we are going to now graph this. Here we have a table, and we're going to graph our data. So we're looking at Instagram posts, the number of posts, and the number of likes. So at 10 likes, at 10 posts, we have 2 likes, which is about right here. then 10, and then about right here. And then we have 15 posts, and we have 8 likes. 20 posts gives us about 12 likes. 25 posts gives us about 14. 25 gives us about 20 for this person. For 30, we get about 20 likes. 40 posts, we get about 32. And 50, we get about 34. So you can see we have a positive correlation. So let's write in a line of best fit. That's not the best. And I'm going to try that again, because we do want it to best represent. So let's go more this way. Okay, so we have 0, 0. And then let's use this value here. This looks about 50, 35. So our rate of change is going to be 35 minus 0 and 50 minus 0. So 35 divided by 50, and that's going to give us roughly about 0.7. This is a positive correlation, and it looks pretty strong. Our B value is 0, 0. And our equation, our line of best fit for the equation is 0.7 times x. Let's plot these points, so miles traveled and fuel in the tank. So when someone goes 0 miles, they have 18 gallons in the tank. When they go 80 miles, so these are going up, looks like by 80. Okay, so and then at 120, we have 12 gallons. At 160, we have 10 gallons. At 320, we have 8. At 480, we have 8. At 480, we have 6 gallons. And this data point at 640, there are 6 gallons. And at 800, there are no gallons. So this definitely has a negative correlation. The more miles you travel, the less gas fuel you have in your tank, and it looks pretty strong. Let's pencil in a line of best fit. And we're going to use the points. Let's use 0.80, 18, and 800, 0, the two intercepts. So we have 0 minus 18 over 800 minus 0. This gives us negative 18 over 800. We're going to divide that out. It's going to be negative. We do have that negative correlation. 18 divided by 800 is 0.225. We have a y-intercept of 0, 18. Our line of best fit equation, negative 0.225 times x plus the 18. And I hope this helps.